part 2 of L'Hopital's rule and indeterminate forms, and we left off with this infinity minus infinity indeterminate form. And we were able to, in this particular case, essentially with the trig functions, very classic thing, you convert them over to the sine and cosine counterparts and then combine them together, and we were able to make a fraction then out of that. 0 over 0, indeterminate form, use L'Hopital's, and we got to an answer of 0. So the last forms that can be adjusted to work with L'Hopital's rule are these following kind of power-based or exponential-based forms. We have maybe 1 to the infinity. And remember, this is a limit 1, so maybe it's a little bigger, and you raise it to enough power, in this case infinite power, maybe it grows to something other than 1. 0 to the 0 power. We don't really know what to do with that. And then infinity to the 0 power. And again, keep in mind, these 0 powers aren't necessarily exactly 0. So we can't just say, oh, they're going to go to 1. That may go to something different because the power isn't exactly 0. They're limit zeros. But at any rate, any of these 3 forms, you will use the natural log to get to the form 0 times infinity, which we just saw in a previous example that can be adjusted to become 0 over 0 or infinity over infinity, which then allows for L'Hopital's rule. So let's go ahead and put that into play in this example here, see how this process works. So we're looking at limit as x goes to infinity of x to the 1 over x. So this will give us infinity, 1 over infinity will go to 0, so we get this infinity to the 0 result. So when this works, it comes out to be this scenario, we got to do this adjustment. So what we start with is we say, okay, we're going to let y equal to x to the 1 over x power. And then we're going to introduce the natural log on both sides. Why? Well, the natural log has a wonderful property. In fact, all logs have this property where you can just move that power down to the front as multiplication. So now what we're looking at is the limit as x goes to infinity of this natural log of y is equal to the limit as x goes to infinity of 1 over x times the ln of x. And in this case, what we're going to get then is 0 times infinity. I can actually work with this. So we'll go ahead and just kind of pull this piece down, since it is the main piece we're going to work with. And one thing we have to keep in mind, we adjusted this with a natural log. We'll have to do something later to undo that. But for right now, let's just run forward and get an answer here. So what I can do with this, basically I could combine these just into a fraction. 1 over x times the ln of x is the same thing as ln of x over x. And now what I'm looking at is an infinity over infinity scenario. I have that scenario. So I can use L'Hopital's. I can take the derivative of the top and the derivative of the bottom and see if I can get to an answer. And in this case, the derivative of the top, the natural log of x, will go to 1 over x. The bottom just goes to 1. And if you do x to infinity now, you basically just get 0. 1 over infinity will go to 0. So that's nice for that. And actually I should unbox that because we're not quite done. I'd like to just stop there, and some of you may stop there as you're practicing these initially. But we have to remember, this is just the limit as x goes to infinity of the natural log of y. So really what we have here is that the limit as x goes to infinity of the natural log of x to the 1 over x, remember that's what we let y equal way up here at the top, y was that x to the 1 over x. Then we did the natural log of that. So we really have the natural log of x to the 1 over x. Its limit goes to 0. Well, I don't want that. I want the limit as x over 1 over x. What's the limit of that as x goes to infinity? So what we'll do here is just make the conversion. So we'll have the limit as x goes to infinity of x to the 1 over x is actually equal to the e to the 0 power. So you just put that 0 that you got from the natural log result up into the power of e, and then e to the 0 is 1. So the answer to this is actually 1. So that's something to keep in mind with this last form of the indeterminate forms, any of the ones with the powers. Whatever you get here after you have put in the natural log so you can move things around, to get the true final answer, you need to put that result into the power of e, because you're changing back from natural logs to the regular form, the original form. Okay, so that finishes up the L'Hopital's, and hope that gives a good base for working with that, and thank you for watching.